I'm over the top. I'm out of here. All right, here we go. Lesson 30. Okay, quiet girls, please. Okay, so today we're going to be determining least common denominators. We are going to add and subtract fractions, and we're going to solve equations that involve fractions, okay? So everybody stick right with me. Stay super calm, and you're going to be great. Okay, everybody on the side of question 1, I want you to write down 2/3 plus 1/2. That is not the problem. But if it was the problem, I can't add fractions until what? Until the bottoms are the same, okay? Here's how we're going to find a common denominator, because it does get a little confusing, I think. You find the biggest number that's in the denominator. That would be a 3. Okay, I want you to write down the multiples of 3. Everybody do this with me. 3, 6, 9, 12, 15. I'm going to stop right there. If that's not enough, I can go back and continue my list in a minute. Now what I'm going to do is I'm going to take the other number, or there might be more than one other number, and I have to find the smallest that's in that list that the other number goes into. So does 2 go into 3? No. Does 2 go into 6? Yes. So the least common denominator would be a 6, and I'm done. That's it. Okay, let's do the next one. Okay, just stick right with me. Stay nice and calm. This is a 4 and this is a 1. You choose the multiples of 4. I'm not even going to write them down. 4, 8, 12, 16. I have to find, the smallest that the other number goes into. That would be a 1. Well, if I wrote down the 4, which is the first one, 1 goes into 4. So that's it. It's just going to be a 4. Okay? Now, this guy has 2 x's and this guy has 1 x. I have to take the most x's that anybody has. So if this guy has 2 and this guy has 1, I don't need 3. Nobody has 3. How many do I need? 1. What's the most that anybody has? If this guy has 2, then I have to take 2 because someone has 2. That's your least common denominator. Okay? Let's come right here with example 3, and I want you to change the 3 on the bottom. I want you to change it to a 7. Okay, so 7 and 2. The multiples of 7 are 7. 2 doesn't go into 7. And then 14, and 2 does go into 14. So there's my number, okay? I want you to talk to me about the A's. How many A's do I need? 1. Just 1. Nobody has 2. Most anybody has is 1. Talk to me about the B's. 2. If you say 3 B's, you'll literally miss the entire question, because I bet 60 plus percent of your test is all or nothing. A lot. So you got the whole thing right, you make that a third, you lose every single point. So you have to be very, very careful. Okay? Okay, here we go right here. See the x minus 1? It's not an x, and it's not a minus 1. It's an x minus 1. So these go together, okay? The x, he's alone. Some people think this, don't write this down, but some people go, well, this has an x, but it's missing a minus 1, so I can just do a minus 1. You can't do that. Doesn't work like that. So you have to have an x, an alone x. This guy has 0. This guy has 1. What's the most that anybody has? 1. You have to have x minus 1s. How many x minus 1s do I need? Just 1. Nobody has more than 1. That's my answer, and I'm done. Who says, I get this? It's fine. I'm totally good. Okay. What number? Yes, everybody freeze for 2 seconds. Yes.
What happens to the top number?
Right now, we're just determining the least common denominator. Thank you for saying that. In a second, we're going to actually add those.
Okay.
But for now, we're just taking like baby steps. Yes. Everybody freeze. Don't go ahead of me, okay? Yes.
For that least common denominator, could you distribute the x into?
You could, but I would never do it. You don't need to, but yes, you could. I think if you do, it's going to confuse you. Okay? Okay, over here. Do you start with the big guy or do you start with the little guy? You start with the big guy. So everybody go 40, 80, 120, 160. If we need more later, we can add more. Does 15 go into 40? No. Does 15 go into 80? No. Does 15 go into 120? Yes. So it's going to be 120. How many X's do I need? Everybody in the room just shout that out.
2.
I need 2. Yes. How many Y's do I need?
3.
I need 3. That's my answer. That's my least common denominator. Done. Okay. Who says this is easy? Let me see. Okay, good. Okay, let's keep going. Now we're going to actually start adding and or subtracting these together. Okay. You guys, what some people do is this. Look right here. Just look forward for me, okay? You have a pizza. The pizza's cut into 10 slices. You take one piece of pizza and you eat it. And then you realize you're still hungry and you take 2 more pieces of pizza, okay? So you took one of the 10 slices and then 2 of the 10 slices. So does that mean that you ate 3 entire pizzas? No, that's what that would mean, and that's not what you did. You ate 3, tell me, of the 10 pieces. So the 10 stays at 10, and then 1 plus 2 is a 3. So don't forget about the denominator. Some people will not write the denominator, okay? Okay, here we go. Step number 1. Factor the denominators. I'm a little bit afraid that some of you are starting to creep a little ahead of me. I want you to remember that this is a times 4. Okay? So please, please just stay with me because it gets tough fast. Okay, step 1, factor the denominators. Step number 2, figure out the common denominator. Next one, figure out what things are missing. Multiply and figure out the top, and then simplify. That's all we're going to say. Okay, here we go with number 4, nice and slowly. The biggest number is an 8. We're going to do one big fraction bar. The biggest number is an 8. Do 6 and 4 both go into 8? No. The next multiple at 8 is 16. That doesn't work because 6 doesn't go into 16. The next multiple of 8 is 24, and that one works. So this is going to be 24. There are no X's or anything like that. Okay, everybody watch this right here. Look at this first guy right here. The denominator is a 6, but I'm turning it into a 24. So I have to go 6 times 4 is 24. Well, then if I multiply the bottom by 4, I also have to multiply the top by 4. So now I have 5 times 4, which is 20. Okay, let's do the next one. That denominator is a 4. What do I multiply by 4 to get 24? A 6. So 6 times 5x is 30x. Okay, do the last one. What do I multiply by 8 to turn it into a 24? 3. So a negative x times 3 is a negative 3x. Am I done? No. Clean up the top, right? So you have 27x plus 20 over 24. Everybody freeze right here. Right or wrong? 27x plus 10 over 12. Right or wrong? Wrong. It's what?
Rude.
It's rude. Who is it rude to?
27.
The 27x. If you're going to reduce, you have to involve everybody. 2 does not go into 27. You cannot do that. That's your answer. Okay? Who says, I'm good. I totally get this. Okay. Good. We're just taking baby steps. Okay. Common denominator. 9 and 6. Do you start with the 9 or do you start with the 6?
9.
Always the big guy, right? 9. 6 does not go into 9. 9 times 2 is 18. Does 6 go into 18? Yes. So it's going to be an 18. Anything else down there besides the 18? An X. Okay. This one is tough, so I want you to watch closely, okay? There's a little twist on it. Okay, look at that right there. What do I multiply by 6 to get 18. That'd be a 3. But I also need an x, right? So I'm multiplying the top and the bottom by 3x. Tell me one word that tells me what I need to do right now. Distribute. You guys are so wonderful. Distribute, and you get 12x squared plus 3x. Look at the middle fraction. What do I multiply by 9 to get 18? A 2. And I also need an x. So now I'm going to go a negative 2x times a positive 2x is a negative 4x squared. Here comes the tricky part. Okay, look at the last guy. He has the x, he's missing the 18. So I have to multiply top and bottom by 18. I want someone to raise your hand right now and tell me what we have to be so careful about. Say it? No.
Oh, it's the negative out in front.
It's the negative. This negative, what you're doing, write this down. Write negative 18 times 2x plus 1. So the negative gets distributed with the 18. So that is negative 36x minus 18, not plus 18. It's minus 18. Take your pencil right here, draw an arrow to the negative, and I want you to say, be careful. Distribute. Okay, now let's clean it up. 12x squared minus 4x squared is 8x squared. 3x minus 30x is a negative 33x minus 18 over 18x. Is the answer to what I'm about to ask you yes, or is it no?
No.
The answer is no. What am I going to say to you? Can you reduce? What guy's messing this up? Out of those 4 people, can you see 4 people? Out of those 4 people, who's the guy that's messing it up? The 33. Yeah. The 8 and the 18 and the 18, 2 goes into all those, but 2 doesn't go into 33, so it's not going to work out. Okay, here we go. Question C, super slowly. Are these highlighted, B and C? Let's highlight them. So let's take our highlighter and highlight those guys. I'm going to add some highlights to this, okay? Okay. Draw your line. Maybe. There we go. Okay. So, 3 and 6, numerically, what are we talking about? 6. X's, how many? Just 1. How many Y's? 3. Okay. So, look at this first guy. You're comparing the denominator of that green guy to the main denominator. 3 times 2 is 6. I have 1x and I need 1x, so I'm good. I have 2 y's and I need 3, so I'm missing a y. So I'm going to take this 2y and distribute it across the top. So I have 2xy plus 4y squared. Okay? Look at the second fraction. I need a 6, I have a 6. I have an x, I need an x. I have a y to the third, I need a y to the third. I have everything I need. You write down on the top of that on the numerator what you think comes next. Write it down. Finish the line right here. Finish what goes on that top. Okay. Negative 2y to the second minus 5. Is that right? That's wrong. And that's the biggest mistake that people make. They don't change the signs of both of them. Who says I understand that? Okay, wonderful. Okay, so the bottom is 6xy to the third. 4y squared minus 2y squared is 2y squared plus 2xy plus 5. How many people are in this group? 4. What's the answer to the question? Yes or no? No, who's ruining it? The 5. You guys are rock stars. Seriously, I'm so proud of you guys. I just feel like we're getting strong.
Way better than 13.
So that
They were good today.
is it change it because it's a negative 5 times by negative outside.
You're taking this negative right there and distributing it to 2y squared minus 5. Yep, and that's where people mess up. Come on. Okay, here we go. Now, it looks different. We have binomials now instead of monomials. So when up above, it said on step 1, factor all the denominators. Okay, so the first denominator, I'm going to take out a 2, and I'm left with x plus 4. The second denominator is already factored. There's nothing to do. So on the bottom, I have to have a 2 because of that 2 right there. How many x plus 4s do I need? Somebody tell me.
1.
Just 1. How many x minus 4s do I need?
1.
Just 1. Okay, so look at this first fraction right here. He's got the 2. He's got the x plus 4. He's missing the x minus 4. So I'm multiplying the bottom by x minus 4. Therefore, I have to multiply the top by x minus 4. Distribute, and I get 3x minus 12. This guy right here has the x minus 4. He's missing the 2 and the x plus 4. So I'm going to go like this, 2x plus 4. So I've got this x plus 4 here. What do I have in front that I'm distributing? Somebody tell me that. I have a 7x and I have a 2, so I have a 14x, correct. Now let's distribute, and that gives me 14x to the second plus 56x, and that's it. Now let's clean it up. 14x to the second, 3x plus 56x is 59x minus 12 all over 2 times x plus 4 times x minus 4. Cannot cancel. There are really only, I don't know if you see this right, there are really only 4 people in this picture still. I know that's weird, but it's 4 people. Look, person, 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 that's all one thing because it's all multiplied together. Okay, I can't do anything because the 59's ruining it, so there's nothing I can do. Okay, who says I'm good?
If you could simplify it, then would you simplify in the parentheses too?
So here's what you do. Like if this were a 60, don't change your notes, but if that were a 60, then I'd go divide everything by 2. So it's 7x to the second plus 30x minus 6 over x plus 4 times x minus 4. You okay?
Yeah.
Good question, honey. Okay, question E. Step 1, factor. Okay, so the first denominator is factored. The second one is factored. The third one factors to x plus 2 times x minus 2. Common denominator. How many x plus 2's do I need? Everybody tell me.
1.
Just 1. Nobody has more than 1. How many x minus 2's do I need? Just 1. This one's super tricky. Okay, super slowly. Look at this guy. He's got the x plus 2. He's missing the x minus 2. So I'm going to multiply the top by x minus 2 and the bottom by x minus 2. Everybody watch. This is not correct. X plus 1 times x minus 2. Nor is this x minus 2 times x plus 1. They're both wrong. On the top one, only the 1 is multiplied by the x minus 2. On the bottom one, only the negative 2 is multiplied by the x plus 1. So you could tell me in one word what I have to do right there. Can you tell me? It's called FOIL, remember? It's the backwards factor. Yep, it's okay. You know what you mean. So I'm going to put parentheses right there. I have a binomial times a binomial, so I have to FOIL. So this is x to the second. And then I'll just FOIL it out. So plus x minus 2x minus 2. I just don't want to confuse anybody. I just didn't do it in my head. Okay, look at this guy right here. He's got the x minus 2. He's missing the x plus 2. Again, I have a binomial times a binomial. so I have to FOIL. When I do that, I get x to the second plus 2x minus x minus 2. This guy right here is not missing anything. Write down right there what you think goes. Finish that line off. And then just stop right there, please. Okay, so it's minus 2x to the second. Talk to me. Plus x, keep going. Plus 5. Everything changes. Wonderful. Look what happens right here. 1x squared and 1x squared is 2x squared, and a negative 2x squared goes away. A positive x and a negative x goes away. A negative 2x and a positive 2x goes away. So what I have left is 1x. A negative 2 and a negative 2 is a negative 4, plus 5 is a positive 1 over x plus 2 times x minus 2. Can I cancel the x's? Can I cancel those? No. See this x plus 1? It's not going anywhere, not the x, not the 1, unless I have exactly an x plus 1 on the bottom, which I don't, so there's nothing I can do. Raise your hand if you're good. Let's see. Okay, let me ask you a question. Do you see how I put parentheses around the x plus 1 at the top? Is that necessary? No. No, so don't get freaked out about that. Okay, question F is highlighted, right? And my comment would be, don't count on it. Because I think we highlighted some things up above here, like this guy and this guy, right? So question F is going to be like, well, that was easy. Yeah, don't count on it. Okay, all right. Common denominator, put them together, y plus 1 times y minus 2. This guy right here has the y plus 1. He's missing the y minus 2. Distribute, and you have 4y minus 8. This right here, you've got the y minus 2. You're missing the y plus 1. So distribute the 3, and you have 3y plus 3. Clean it up, 7y minus 5 over y plus 1 times y minus 2, and there's nothing you can do. Who says, I'm fine, I am totally fine? Okay, yay. Okay. Question 5. What is the difference between x minus 4 and 4 minus x? They look very much the same, right? Everybody write down, which one looks weird? X minus 4 or 4 minus x? The 4 minus x, right? So let's write it down. 4 minus x. First of all, the variable usually comes first. So let's write it as negative x plus 4. And now it looks weird because you have a negative in front of it, right? Well, let's just factor out a negative. So if you factor out a negative, it changes both of those signs and you have x minus 4. So 4 minus x is x minus 4. Finish my sentence. Multiplied by a negative. Yeah, let's write that down. So I'm going to say 4 minus x. Let's put that in parentheses just so we don't get confused with what we're saying. 4 minus x is x minus 4 in parentheses multiplied by a negative. So keep your eyes out for strange things like that as you go through these problems. Let's do this problem. So everybody go 4 minus x over x minus 4. What one looks weird? The top one or the bottom one? The top one. So leave the bottom the way it is. And let's try to change the top so it doesn't look strange anymore. So reorder it, negative x plus 4. Tell me what to do now. Take out a negative, and you're left with x minus 4. And then on the bottom, you have x minus 4. Somebody talk to me about that. Now they cancel, because I have the exact same thing. So those cancel, And my final answer is a what, everybody? -1. Yeah. Good. Okay, right here. Hopefully now you look at that problem and you look at the denominators and you're like, I think it's that negative thing, right? The first denominator looks fine, so write that down. The second denominator looks strange, so the first thing I'm going to do is reorder it. Now that I've reordered it, I'm going to take out a negative, so it's going to look like that. When I take out the negative, it changes the signs. Well, now look what I've got. I've got an x minus 1 and an x minus 1. So I have a common denominator. Yeah, there's a negative down there, but look what we're going to do. We're just going to go positive times a negative. What's a positive times a negative, everybody? Negative. So just erase that and put a negative right there. And then your denominator is x minus 1. On the top, a -2 and a -6 is a -8. And that's it. Yes?
So why wouldn't those cancel out, like x minus 1 minus x minus 1?
Okay, so that is like, yes, that's like saying this. Look, sweetie, remember 1/10 of the pizza,
Oh yeah.
and then 2/10 would be 3 pizzas. It's 3/10, right? Okay, good, honey. Lots of great questions from you today. Okay, so now we're going to change our focus. I feel like the lesson, it's more than halfway over, but in terms of concepts, halfway over. Because this one's done. I feel like we're really good. Do you feel like we're really good on that? Now we're changing, okay? What's different? Look at that problem right there. What's different? Tell me that. You have an equal sign, which means your answer is going to be x equals something. We're solving, okay? Okay, so I want to ask you one question before we jump into this. When you have a fraction, tell me restrictions on that fraction. Any value restrictions on that fraction?
Yeah, the denominator can't be 0.
Yes. So everybody write down, the bottom cannot be 0. You can never divide by 0. It's a domain restriction. Okay? All right, here we go with question 7. It's different. Don't get confused. You know what I'm a little afraid of? I'm going to be honest with you. I'm afraid that now you understand what I just taught you. Everybody's good? I feel like this is going to mess you up. Because it's an equal sign, which means you do it different. So look right there. I'm not going to get a common denominator. The time you do get a common denominator is if you're adding or subtracting. If it's an equal sign, you wipe out the denominators. You get rid of the denominators. So you've got to understand the difference. Get them if you're adding or subtracting. Get rid of them if it's an equal sign. Who says I understand what you're saying? Let's see. Okay. Step number 1, factor all the denominators. Step number 2, figure out what the least common denominator would be if you were getting one. Multiply everything by what it would be, and then solve it. Okay, here we go, nice and slowly. Okay, nothing factors. None of those denominators factor. If we were to get a common denominator, everybody in the room tell me what it would be. 3x. So there are 3 people in this picture. So I got to multiply this person by 3x, and this person by 3x, and this person by 3x. And now look how sweet, guys. Look what happens. See that first fraction? Do you see that x that was creating the problem? It goes away because that x cancels with that x, and I have 15. Look at the next fraction right here. This 3 cancels with this 3. This x cancels with that x, and I have a plus 4. On the right-hand side, there's no denominator to cancel, so it's just 10 times 3x, which is 30x. That looks way easier than the original problem, don't you think? And it's the same equation. It just looks different. So now we have 30x equals 19 divide by 30, and you get x equals 19 over 30. That's your answer. By the way, the first thing I want you to do on these problems is list your restrictions. So look at that problem, and someone shout out a restriction on the value of x. Is there one? It's a 0. All you do is set all the denominators equal to 0, see what you get. That just tells me x cannot be a 0. X cannot be a 0 because then I'd be dividing by a 0, which I can't. Okay? Okay, everybody, look right there. Freeze for 2 seconds. Am I getting a common denominator or am I getting rid of the denominator? Getting rid of. If I were to get one, which I'm not, but if I were, what would my common denominator be? Did you say 4? It's not 4x. It's not 4x. Remember, you take the big guy, 5. Does 4 go into 5? No. Then you try a 10. 4 doesn't go into 10. 15. 4 doesn't go into 15. 20. It works. So the correct answer is 20x. Who says, now I'm with you? Okay. Freaking me out a little bit. Okay, so this is 20x and 20x and 20x. You guys, the denominator is always going to cancel away. Always. So this x cancels with this x. 20 times 5 is 100. Yes?
Wait, why don't you times the 20 on the bottom too?
Because I don't have to. Because it's like this. Look at this. 5x equals, let's do it like, 5x equals 10. To solve that equation, honey, I just divide by 5. And I get x equals 2. So that's like saying, if I'm dividing by 5, why don't I multiply by 5 also? Because I don't have to. I'm just trying to get rid of that 5. You okay?
Yeah.
Okay. Then look at this next one right here. 4 goes into 4 once. 4 goes into 25 times. 6 times 5x is 30x. And then on the very last one, the 5 is always going to go away. 5 goes into 5 once, into 24 times. 4 times 4x is 16x. Way easier. Knock them out. Okay. Move your 30 over, it becomes a negative. So I have a negative 14x equals 100. Divide by negative 14. And I get negative 100 over 14. Is that acceptable?
No.
No, reduce it. So x equals negative 50 over 7. Now, before I say yay, I'm done, I have to make sure that negative 50 over 7 is not a restriction. And like I said, I want to start that way, but I keep forgetting to do it. And I want you to actually write it down. Do I have any restrictions as to the value of x on this problem? Yes, what it is. What is it? X can't be 0. Yep. So our answer is really our answer. What if I got a 0 when I solved it, but 0 was a restriction? What would the answer then be? No solution. Good. Okay, here we go with question C. Now, this is the, yes.
Okay.
Freeze for 2 seconds, guys. Okay, go ahead, honey.
Like, why do you do times all the top ones by 20x? Like, wouldn't you do it like by, because it's 4, so wouldn't you do it by like 5x? Is that your
Okay, I know what you're saying. Okay, look right here. Here's my problem. Okay, watch me do this. Multiply by 5x, 5x, 5x.
Well, like,
Is that what you're saying?
I'm saying like, so the 5 over x has an x, so I would just multiply it by 20.
No. You don't multiply by
Oh, yeah,
what's
'cause you're not
missing.
trying to get it.
You multiply everything by the same.
Okay.
You okay?
Yeah.
So you know what's starting to happen to you? You're starting to mix them,
Yeah.
right? So freeze for 2 seconds. Everybody look right here. Some of you are sitting down. Sit up, please. Okay, look right here. I want you to write this on the side somewhere. You ready? 5 over x minus 2 over x squared. Line. 5 over x minus 2 over x squared equals 1. The difference between these. The guy on the left, common denominator, x squared. This guy has 1x, he's missing an x. So I'm turning it into a common denominator, so I have a 5x. This guy's not missing anything, so I go minus 2, and I'm done. This guy, I get rid of the denominator. So when you have an equation, you can multiply everything by the same thing. So now this x cancels with one of those, and I have 5x. These x squareds cancel, and you have minus 2. 1 times x squared is x squared. Now this didn't turn out very clean because I just made it up in my head. I'm just going to show you what the next step would be. Pull that over. X to the second minus 5x plus 2 equals 0. And then what would we do here? Quadratic formula. We're not even going to go there, but you get the idea. Look at the difference between those two. If you're adding or subtracting, you must have a common denominator. Everybody knows that. If you're solving, you don't need a common denominator. Knock them out. I hate them. So get rid of them. I don't need it. Who says I understand? Raise your hand. Okay, let's go back. Thank you. Okay, here we go. Question C. Do I have any restrictions on my value of r? Look at the denominators. Do I have any r's down there? No, no restrictions. Everybody in the room, answer this question. Getting a common denominator or getting rid of the denominator? Getting rid of. What would it be if I were getting one? 12. So I'm going to go 12, 12, 12. This guy right here, 12s cancel, and I have an r. This guy right here, 4 goes into 4 once. 4 goes into 12 3 times. 3 times r is 3r. On the right-hand side, do I have a 1? What do I have? A 12. Now I have 4r equals 12. Divide by 4, r equals 3. I'm done. Okay, D. Getting a little tougher. Factor, nothing to do. Factor, take out a p. Factor, nothing to do. Get a common denominator or get rid of the denominator? Get rid of. So what would it be? I would need a p. A p to the first, everybody, or a p to the second? Look at the denominators. Do I have any p's that are alone that are squared? Do I have any? No. So I don't need 2. Nobody has 2. The most that anybody has is 1. Who says gotcha? Okay. What else do I need? P minus 3. Everybody in the room, how many P minus 3s do I need? 1. Because nobody finished my sentence. Nobody has 2. Nobody has more than 1. If you can't figure that P times P minus 3 correctly, I'm sorry to be harsh, you're going to miss the whole thing. Because you're going to end up with this equation down below that has like P to the 5th in it or P to the something big, and you're going to be like, what the heck happened? It's because you chose too big of a denominator. Okay? Okay, right here. P minus 3, 5P equals. Right here. The denominators are always going to go away. Goes away, goes away, goes away, goes away, 1. This guy right here, the P on the bottom cancels with the P on the top, and I have P minus 3. Now just solve for P. So just take this P right here, pull it that way, and I have 4P equals negative 2. Divide by 4. I get a negative 2/4, which is the same thing as a negative 1/2. What did I forget to do that I've forgotten every time? Restrictions, yes. So look here. You tell me, what are the restrictions? P can't be 0, nor can it be 3. Yes. Do I want you to write that down? Every time. Even if, what if they don't ask you to write it down? Write it down.
How do you get the, how do you know
Set,
the restriction?
just take that equal to 0. This was P times P minus 3. Set that equals 0, that equal to 0, that equals 0. If you set P minus 3 equal to 0, you get P equals 3. Set P equal to 0, you get P equals 0. Those are the values that P cannot be. Okay? All right, here we go. 10 and 11, I want you to highlight those. And those are the booty kickers. They're the ones that are going to kick your booty. And we just added highlights to them. Okay? Are you smart enough to do this?
Yes.
Yes. Everybody say yes.
Yeah.
Yes. It's just if you choose. It's a choice. Do you work hard and get it, or do you not work hard? That's the question. Okay. Look at the denominators. Which one looks weird? First one or the second one? Second one. So leave the guy that looks normal alone and make the other guy look different. See the question mark? I could keep writing a question mark. I think that would make you feel uncomfortable, like concerned. So we're just going to let it be an A. Can let it be an, I don't want to do X because I've got other X's, right? So I'm going to rewrite the bottom as negative X plus 1. Now, I'm going to take another step, and I'm going to, what am I going to do now to that denominator? Take out a negative, and I'm left with X minus 1. See this negative right here on the bottom? Is there somewhere else I could write it if I wanted to? On the top. So let's erase it and put it on the top. And now look what I've got. This denominator is the same as that denominator. Therefore, that numerator must be the same as that numerator. So I know negative A must be 2. So I know A must be, tell me, negative 2. That's it. Question 9 might hurt your brain just a little. Okay? So hang on. Which side looks weird, the right or the left? I think the left looks good. The right looks weird, right? So let's leave the left the way it is. And let's change the right. So the first thing I'm going to do is, what's the first thing I should do? What do I always do first on those other ones? Reorder, right? So negative 3x plus 2 and negative 4x minus 1. Okay, it's just a little tough to understand this, so listen closely. What do I need to do to this to make it look like that? What do I need to do? Pull out a negative. You guys are so good. So keep the left normal. Then put your equals. Then put a negative. And change both the signs of that, what I underlined, and I get 3x minus 2. Now I'm going to do another step right here. What do I have to do to him to make it look like him? Pull out another negative. So I know this is like not mathematically sound, but I'm just going to stick a couple of negatives out there. We'll talk about it in a second. Then I'm going to change the signs, and I have 4x plus 1. Somebody talked to me about that. A negative times a negative is a positive. So is the answer true or is the answer false? The answer is true. Those things are equal. Because if you factor 2 negatives out of the right side, you get the same thing, and a negative times a negative is a positive. The why or why not is your work. It's totally sufficient. Okay. Who is still hanging on with me? Who's like, I'm good. I feel okay. Even if you're like halfway hand, it's okay. This is like, I'm a rock star. This is like, I feel pretty good. Okay. Most of us are somewhere in there. Okay. This one's tough. This one's tough. I'm just warning you, okay? I'm changing the problem, and I want you to cross that out. The r sub 1 equals and r sub 2 equals. Okay, look at the problem. One variable is an r. A different variable is an r sub 1. A third variable is an r sub 2. They could literally be x and y and z. Do not get scared by those variables. It's just a sub number. Who cares? I'm even going to say, let's just make them x and y and z. Now, I wouldn't normally do this on a test. I just want to calm your nerves. So everybody write 1 over x equals 1 over y plus 1 over z. There is no difference between what I just wrote and the original problem except for the name of the variable. Who cares? That's not scary. We're going to still go with x, y's, and z's. Over here, they wanted us to solve for r. Well, that was my r. So we're going to solve, or we're going to find what x is. Okay? Stay right with me. Get a common denominator or get rid of them. Get rid of them. If I were to get, what would it be? In terms of x and y's and z's. In terms of that you see right there. X, y, z. 1x, 1y, 1z. Right? So go x, y, z. X, y, z. X, y, z. Do you understand what I just did? Okay. This fraction right here. The x cancels with the x. 1 times yz is yz. This guy right here. The y cancels with the y. 1 times xz is xz. This guy right here. The z cancels with the z. 1 times xy is xy. Who says I'm good? Okay. Watch me do this. Don't write anything. Why do I say that to you? I'm about to do it wrong. I don't want you to write it wrong and then erase and your paper's a mess and you're confused, right? Watch me do it wrong. I'm trying to solve for x. I'm going to take this guy and pull him that way. So now I have xz equals yz minus xy. I want to solve for x, so I want to get rid of the z. So I solve by dividing by z. So I have x equals yz minus xy over z. There is one reason why that's wrong. One reason why that's wrong. I didn't do anything wrong algebraically. That's not right. Someone tell me why it's not right. I solved for x, but I still have an x over there. That doesn't make sense, right? That's like saying this, guys, look. X equals 4 plus 2x. Yay, I just solved for x. No, you didn't. There's still an x over there. You didn't do that. Who says I get that? Okay, so that's not what you do. Some things have x's. Some things don't have x's. It just so happens that everything has an x is on one side. Everything that doesn't have an x is on the other side. Well, that's sweet. But I can't add xz to xy. They're not like terms. So how in the world what am I supposed to do now? If I'm trying to solve for x, but I can't add those together. Someone last period figured it out. They told me what to do. Look at it. How can I isolate the x? We don't divide by anything yet. I heard lots of chatter, but I only heard a couple of voices. Does anyone feel pretty confident what the next step might be? How can I get the y, or the x, pardon me, how can I get the x alone? How can I pull it out of those? Go ahead. You factor the right. And what do you do exactly, honey, to factor the right? What are you talking about?
So
Someone right here said it. You're right. Somebody helped you. What'd you say? It was a girl. Of course it's a girl, right? I'm just kidding, guys. What do? You take out the x. Then what? When you take the x out, what do you left? Z plus y. Now I want to get, watch guys, now I want to get the x alone. The z plus y is multiplied. So to get rid of it, I have to divide by z plus y. Now the z plus y's cancel. Now my x is isolated. So x equals yz over z plus y. Can I cancel anything? No, it'd be rude no matter what you do. Wouldn't work out. Who followed me? Do it all the way to the sky if you followed him. Okay, same thing again. Solve for capital T. Here we go. Get or get rid of? Get rid of. I'm not changing the T sub 1 and T sub 2. You guys are smart enough. It's just a variable. One time when I was in college, the professor had us do a variable like, I don't know, some scribble. And we had to keep doing the same scribble. He was just trying to say it doesn't matter. It's just a placeholder for whatever that ends up being. Okay, so don't let those freak you out. Okay, so I'm going to multiply by T times T sub 1 times T sub 2. That's three things. This guy right here, the T sub 1 cancels. They both cancel. And then I have a capital T times T sub 2. There are two variables sitting there. This guy right here, the T sub 2 cancels. And what I have left is a capital T times T sub 1. On the third fraction, the capital T cancels. And so what I have left is T sub 1 times T sub 2. Now let's see if you can figure out the next step. I'm trying to solve for capital T. Luckily, both of those capital T's are on one side, but I can't add those two terms together. Now tell me what to do. Factor more information. Factor capital T. Yeah, when you factor capital T, you're left with T sub 2 plus T sub 1 equals T sub 1 times T sub 2. People get confused. What goes on the bottom? The T sub 1 times T sub 2 or the T sub 2 plus T sub 1? Which one goes on the bottom? The one that's multiplied by the T, right? You divide by what's there, and then those cancel. So your answer is capital T is T sub 1 times T sub 2 plus T sub 2 over T sub 2 plus T sub 1. That's it. Too many T's. That's it. Who says I'm good? Let me see. Okay. Okay, everybody look right here. I want to see every eyeballs in the room.